This video is an explanation of the definition of the derivative. So what we have to realize is that this word derivative is just talking about the slope, specifically the slope of a tangent line to a curve. Let's start out here with what we know about slope. Back in pre-algebra and Algebra 1, we learned that slope is the ratio of the change in y to the change in x. We also know a formula for the slope, and we use y2 minus y1, the difference in two y values compared to or divided by the difference of two x values. So what we're going to take a look at here is these two, I guess, formulas in a different form. If I take a look at it as f of x plus h minus f of x all over h. So what this is still the change in y over the change in x, and let me just kind of explain why. This is an x value, okay, and we are plugging it into a function. When we plug an x value into a function, the result is a y value. Here's another x value, and we're plugging that into the same function, and the result of that is a y value. Since these two x values are different, the two y values will also be different. So here is y2 minus y1. And look down here. If we take this is an x value, so if we take x2 minus x1, the result simplifies to just be h. Okay, so this, you should recognize this based on what you've seen about the definition of the derivative. Okay, I know there's a little limit we have to put in here, but let's kind of talk about what a tangent line is real fast. If a tangent line is a line that just nicks the curve at one point. So if I were to talk about the tangent line and this being the point of tangency, my tangent line would look something like this. But you might be asking, well, we have to find the slope of this, and the slope uses 2 points, y2 minus y1 over x2 minus x1. How are we going to find the slope at a single point? Because the tangent just touches the curve at one point. And here's where the limit comes into play. We are actually using 2 points when we calculate this slope. But what we're doing is we're taking this point and another point, and we want that other point to be as close to this point as absolutely possible, but still being distinct. And the only way of doing that is to include this limit. So h is approaching 0. It will never be 0, but it's as absolutely close to 0 as we can possibly imagine. Okay? So we did say that these x values were different, and therefore these y values were different. But now think about how close these x values are together. We're taking x plus a number that's so close to 0 only our brains can imagine it. No calculator or computer can even work on that. And here's the original x value. So this is x plus a little tiny bit more, and this is x. So it gets us two different y values, y2 minus y1 over, here it is, x2 minus x1. And what we see right here is our definition of the derivative.